Hey folks, this is the Unit 4 Lesson 6. We're going to talk about some shortcuts to be able to graph lines, connecting both to the transformations that we talked about how we knew from the numbers in the equation if it had shifted up or down or gotten stretched taller. And also we're going to connect this into the way we dealt with lines in Unit 3 using the ROC and the initial. So we're going to kind of connect those two things together and give us some shortcuts for being able to graph lines by hand if we know their equation. So this is going to, instead of doing it on Desmos like we did in class, this will be just being able to graph lines on graph paper without having to go through and make big tables of values. Okay, so the first one is, this actually is my basic line that we talked about in class with the Desmos activity that has the equation just y equals x. So we're going to kind of figure this out, connecting this to our work in Unit 3, where we found the ROC using a rate triangle and found the initial. So I'm going to draw in a rate triangle, kind of arbitrary, and we can assume that each square is 1 unit on this. So I would have a rise of 3 and a run of 3, and I know that the ROC is rise over run, so 3 over 3, and that 3 divided by 3 gives me 1. I also know that the initial is the starting value, so my initial is 0. So remember in Unit 3, we said that the dependent variable equaled the initial plus or minus the ROC times the independent variable. And this is a great way of thinking about it when we have a real life scenario, when we're talking about cost and number of hours, or bank account balance and the number of months, or the total price for a certain number of people. And this is a really good way of connecting that, but we want to kind of generalize a little bit more in Unit 4 so that we're just using we're more just using x and y. So it still works even if we don't really have any idea what this equation is necessarily representing. So we know that the dependent variable, that was our up and down. So my dependent variable, I'm going to use y, and my independent variable, I'm going to use x. So here I would say y equals, now the initial is 0. I would choose plus or minus based on if it's going up or down. And obviously we see that it's increasing, it's going up, plus the ROC, which is 1, and the independent variable is x. So do I really need, we've got y equals 0 plus 1x. Do I really need this 0 here? Not really. Writing out that 0, so y equals 1x, which we know is just y equals x. So remember that that's actually the most simple basic equation that we can have for the equation of a line. We're going to kind of connect, but streamline things a little bit. So in Unit 3, we said that the dependent variable equals the initial plus or minus the rate of change times the independent variable. Now, there's nothing wrong with this equation that we use that whole time, except that it's a little bit clunky and it's a little bit kind of counting on the idea that we will have sort of a real life scenario. And if we don't have that real life scenario, we can streamline this a little bit. And instead of writing out like a whole word like initial, we're just going to give that a variable letter. Same thing with dependent variable and independent variable. I'm going to use the same thing every time for those. So this is y and this is x. And I'm going to use a new letter, B, which stands for the base, for the initial. And for the rate of change, just because ROC, like that's using 3 letters, if we simplify it, we can just use 1. We're going to have M, which stands for multiplier. And we actually do kind of switch the order around a little bit. Instead of having the initial come first, this order, taking the multiplier first and then adding the initial, matches more up with what we did with our transformations. And the initial, or the base, that ends up being your vertical shift. So whether it moves up or down. And especially now that it could be a negative, because we can move that down, which often doesn't really make sense in terms of a real life scenario, but certainly can happen on just a regular graph with x's and y's. So your M is your multiplier, which is the same thing as the rate of change. It's the same thing as the slope or steepness. And it's also the same thing as the stretch factor. All of those things are the same. So we use M. That's kind of a standardized math notation for all equations of lines because it's a multiplier. But if we're talking a real life scenario, we say rate of change. If we're talking, and that is the same thing. If you were describing a graph, you might say how big the slope or the steepness of that graph is. That's the same thing. If you were describing it with transformations, you might say stretch factor. So these are all the same thing. They all are different words for the same thing. And then the B, we're going to use B, the letter B, which really stands for the base. That might be like the base fee or the base cost. But it's also the same as my initial. I don't know why those dots aren't showing up. It's also the same as the vertical shift. It's also often called the y-intercept, so where it starts on the y-axis. So those are all words for the same thing. I'm going to ask you guys to pause this and make sure that you've got this all copied down before you move on to the examples. Okay, so now we're going to go on to an example and talk about how we can graph this. So our first example is y equals x plus 5. So I know that my M is going to be the number with the x. That is my rate of change. That tells me the steepness. That tells me a lot of things. So I'm going to put a 1 in front there because if you don't have a number there, that has to be a 1. So M equals 1. And remember again that that M represents a lot of things we've talked about, but it's all the same concept, just with different names, depending how you're dealing with it. You're going to be able to say that that's the rate of change, that is how steep the graph is, or that is the stretch factor, as we did in the transformations. I also see a plus 5, which tells me B is 5. And remember that that's your initial. So the steps to graph here, we're going to go and first do that vertical shift up or down by the B value. So our first step is to graph B, which is your intercept. That's your y-intercept or your initial value. So I'm going to put a point 1, 2, 3, 4, 5 up. This has an initial value of 5. So I'm going to put a point at 5. That's my initial value. That's my vertical shift. It's moving up 5 from the original y equals x. And then my second step is to use m equals rise over run. Remember, m is just a short form called multiplier, but it means the same as rate of change. So I'm going to use the m equals rise over run to find some more points. So rise over run equals 1, but that doesn't really show me that this is, like, it doesn't show me the rise and the run. So whenever you have a whole number like this, I want to make it into a fraction, and that this will say the rise is going up 1 and the run is going over 1 to the right. So I'm going to go from that point, from the point that I already graphed, and I know that I have a rise over run or a rate of change of 1. So I'm going to count up 1 and over 1 and put another point. And I'm going to do that a couple times. Up 1, over 1, up 1, over 1. So that should give you a nice straight line. Remember, if you're graphing a linear relationship and your points aren't all in a line, then you've done something wrong. Go back and check your work. I, on the other hand, do not have a ruler on my tablet, and I'm just freehanding this the best that I can. So once you get your line drawn, you're going to label it y equals x plus 5. So that's the step 3. Connect points with a ruler and label. And that's all there is to it for this graphing. So here we've got another equation. We have y equals 2/3 x minus 4. Now this 2/3 would be pretty hard to do using a transformation stance, like making everything 2/3 as tall is kind of tricky to graph. But if we look at this as my multiplier or my rise over run, here, if rise over run equals 2/3, that really clearly says, oh, you're going up 2 and over 3. So that's going to be an easier way of looking at this. So my B, my initial value, is -4, and that's where I'm going to start my graph. So my first step is to put a point at y equals -4. That's my initial value, so I'm going to count down 4 and put a dot there. Now from here, I'm going to use the rise over run. I'm going to go up 2 and over 3. So up 2 over 3, up 2 over 3, and put some more points. There's no hard and fast rule as to how many points. Doing at least a couple more is a good idea, just so you make sure that they're all in a straight line, and that's kind of a check as to whether you're counting properly. Like if you miscount the number of squares, for instance, it can be problematic. So this gives me a good picture of where this is going. So draw a nice straight line and then label it. So y equals 2/3x minus 4. So you can pause there, make sure you got that copied down, that you're saying your M, your B, and then explaining the M in terms of rise and run. The M, remember, is just like rate of change. It's just a more streamlined way of writing it. Instead of writing out rate of change and initial, we're just going to say multiplier and base for M and B. Okay, so the next one, we've got y equals negative 4x plus 2. So always picking out your M value and your B value first. M is negative 4 and B is 2. The negative 4 I know is rise over run, but I only have a whole number, not a fraction. So I'm going to want to make that into a fraction by putting it over 1 so that I can see very clearly the rise part and the run part. Now, what does it mean if that rise is negative? We haven't done one like that yet. That just means that it's going down. Remember, we talked yesterday about negatives would be flipped and have a decreasing line. And the run always goes from left to right. So here we've got a B value of 2. That's my first step. To plot that point at my y-intercept, or my initial, is 2. Now I'm going to count the rise and the run, always going from your initial value, from your B. So I'm counting down 4 squares. So I'm going down 4 and over 1 and going to put in another point. So I'm counting down 4 for the rise of negative 4 and over 1 for the run and putting a second point. Then I'll go from that point and count down 4 and over 1 and put another point. Or it's kind of like making the rate triangle but going backwards, using those rate triangles to find points on the line versus having the line there and then using that to find the ROC. It's like if you know the backwards information. So then I'll label y equals, negative 4x plus 2. And my line went a little bit wonky there. I wish I had ruler capabilities here. I think it's probably more like that. So you can pause that, make sure you've got all of that copied down and that you're understanding those steps. Okay, there's one last kind of lines that are a little bit different and don't really follow the same rules. So these kind of lines don't have an equation of y equals something x plus something, like our ROC and initial. And these are a special kind of line. So the first one I want to look at is y equals 6. So we want to figure out what kind of line would have a rule that just says y equals 6. That's not the number with the x. So we don't have like an M and a B necessarily that we can just pick out. Now, the way I normally start this is to say, somebody tell me a point where the y value is 6. And there's lots of different possibilities. You might say, hey, the point 2, 6 follows that rule. Follows the rule of y equals 6. We're just going to make a lot of points. So I'm going to graph that point going over 2 in the x direction and up 6 in the y direction and putting that point in right there. What's another point that follows the rule the y value has to be 6? There's, again, almost infinite possibilities. You might say, hey, what if x is 5 and y is 6? That also follows this rule. So I'm going to go over 5 and up 6 and put a point there. So this is the 0.26. This is the 0.56. We could make a whole bunch of points that follow the rule y equals 6. Maybe I'll say -3, 6, and put that point up here. Maybe I'll say -7 and 6, and put that point there. You could do a lot of points that follow the rule, because this is a pretty simple rule that y has to be 6. As long as the y value is 6, these points follow this rule. So if I went and connected those, that's actually an interesting kind of line, isn't it? All of the points where y equals 6 make a horizontal line. So that's going to be how I graph that. You don't actually need to draw so many points and label them. Eventually you'll get used to that, knowing that that's a horizontal line. Now let's try the next one. X equals -8. This is going to be kind of right at the end of my graph here. But can you say some points where the x value would be -8? That's the only rule we have to follow. We know x is -8. We can have y be anything we want. So I want you to find 4 points where x is -8. And then figure out, okay, well, what would the y values be? You can pick anything. I might pick -8, 1. And I'm going to graph that, going -8 in the x direction, 1 in the y direction. And there we are. I might pick -8, -4. So -8 in the x direction and down 4 in the y direction. I might pick -8 and 3. That one would be there. -8 and -7. So -8 in the x, -7 in the y. So that gives you a whole bunch of points. And what kind of line do they make? That's going to make a vertical line. So if you have this y equals equation, you're going to get a horizontal line. And if you have an x equals just a number, you're going to get a vertical line. And that's summarized on the next slide as well as in your notes. So a horizontal line is going to have a slope of 0. Any horizontal line has this equation, y equals b, and b is the y-intercept, or the initial. But it's flat, it's horizontal, it doesn't go up and down. A vertical line doesn't have a defined slope. We say undefined because it's so steep. It went all the way vertical and you can't even measure the slope. But if you see x equals a number, that's a vertical line. And then you just have to draw that line through that x value up and down. It can be a little bit tricky to remember keeping these straight, that y equals a number is horizontal and x equals a number is vertical. It's kind of the opposite of what people tend to think, because people always think, oh, here's the y-axis, that's vertical. But if you're saying y equals, say, 6, that's all the points where y is 6. So that actually is a horizontal line. And the x equals equation, the x-axis is horizontal, but all of the x values being the same, that ends up being a vertical line. So the last two examples we're going to do is just to find the equation of these lines. And this is going to work really, really the same way as what we did in our Unit 3. Instead of using initial and ROC, we can use M for multiplier and B for the base. So you can still use initial and ROC if you want, though, for sure. Remember that I do want to choose numbers that are nice whole number values when making my rate triangle. Like, I don't want to pick any that are kind of in between. So I'm going to pick there and draw in my rate triangle. And I will label my initial that B is 1, 2, 3, 4, 5. So that's initial of 5. So my B value is 5. And then I'll label the rise and the run. So the rise is 1, 2, 3, 4 down. So I'm going to say -4. And the run is going 1, 2, 3, 4, 5, 6. So the slope, or the rate of change, or your M, you can say rate of change still if that helps you, is going to be rise over run. So rise of -4 and a run of 6. I want to reduce that into lowest terms and say that that's -2 over 3. So then to write the equation, we just put those in, just like for initial, -2 over 3, not -3. -2 over 3 as our rate of change, plus 5 as our initial, or our B. So make sure you've got that copied out. It's very, very similar to what we were doing before, just a bit more generalized because we don't know the context of this question. Last one is, can we find the equation of this line? Now, if you remember, if you've memorized this on the test, for instance, and you know, hey, if it's horizontal, I say y equals, and if it's vertical, I say x equals, then you can go right to the answer here. Because this is a horizontal line, so we know it has an equation y equals, and then we just count. It's 1, 2, 3, 4. So this has an equation of y equals 4. If you forget that, it's still pretty easy to do. If you forget that, I want you to label a bunch of points on this line and see what they all have in common. So I might label that point and say, okay, where did that go? That went 1, 2, 3, 4, 5 in the negatives for x and 4 up. So that's the point -5, 4. And then you might label this point. That goes 1 in the negatives for x and up 4. -1, 4. And then you might label this point. That's going over 3 in the positives for x and up 4 for y. So you can see, oh wait, all of these are the same. If it's horizontal or vertical, one of those is going to be the same. And you notice, hey, that's the y value. So it must be y equals, because those are all the same. And it must be 4, because that's what they all are for all of the points on that line. So you guys can now start the lesson 6 homework, doing just questions 1 and 2. And we'll continue in the next lesson with the additional volume information.